We now continue our basic tutorial with a discussion of the Schedule Analysis tab. This tab and the Precedence Reports tab always operate on all tasks of the schedule, regardless of whether task filtering has been applied. As its name suggests, this tab analyzes your schedule for you and does it in three ways. The first way is by quality diagnostic checks in the left column, many of which are not in P6 or project. The second way is the top right column if a baseline is loaded. VU can provide variance reporting and task comparisons. The third way reports the evolution of the schedule from the baseline to the current, useful in merging schedules and in claims work. At this point, we should mention the date formatting options available on the About tab. Here you can select among 9 common formats. Your choice is remembered for future sessions. The All On-Off button toggles the reporting components. The first two options need to be considered. You may want to report on completed tasks, or you may not because they are history and you can't change what happened. Normally you do want to look at uncompleted tasks so you can intelligently shepherd the project. The Basic Stats option reports things like the number of tasks started, unstarted, and completed, constraint counts, relationship type counts, etc. Over time, this can give you a handle on whether a schedule is being actively developed. This report has 2 columns. Let's run it. One for the baseline and one for the current. Here's the basic stats here, the task completed, started, unstarted, totals, primary constraints, secondaries, expected finishes, rel counts of the various types, lagged relationships, and negatively lagged relationships. Let's review the report component checkboxes below. The Generate Open Ends option will list tasks with no predecessors, no successors, or both. A perfectly tied schedule should have only 2, the first and last task. Generate Lagged Rels shows all those. Lags are not easily evident after applied and sometimes are improperly used instead of task logic. Generate Primary Constraints and Secondary Constraints are self-explanatory. Generate Constrained Actuals will show constraints on started or completed tasks. These are pointless and distracting artifacts, especially if you archive. Generate Non-Operating Front-End Constraints. These are tasks where remaining duration or logic has pushed the start date of a task beyond the constraint, also pointless. Generate Violated Back-End Constraints. This occurs when logic pushes a task finish beyond the constraint. They are still useful but create a negative float condition, which you should be aware of. Generate Violated Project Must Finish By. This will identify tasks that have blown by this project constraint. Did you forget you had applied this? Generate Expected Finishes Before the Data Date. These are either useless artifacts or worse, will cause an unfinished task to have 0 remaining duration when the data date is moved. Very poor scheduling practice. It is always a good idea to review the near-term expected finishes before you advance the data date. Generate original or remaining durations exceeding your threshold. Some schedule specs prohibit long tasks. This will help you remain in conformance. Generate non-PC rels. Opinions vary on these. The start to finish tie is non-real if you stop and think about it, but they can be useful in tying start and finish milestones. Negative lag should certainly never exceed the predecessor duration. Generate calendar non-works and exceptions. Very useful to compare the calendars of 2 non-integrated schedules like owner and GC or GC and sub, or to simply review which non-work days are acceptable on the project. Generate probable data date driven tasks. These are tasks that are riding the data date line. Often they have not been started on time and deserve attention. Generate loose-ended tasks, sometimes called danglers. These will list arrangements of tasks that are different than open-ended tasks. They do have a pred and successor, but one end of the task is uncontrolled. You have loose-ended tasks when you have a start-to-start cascade. You have loose started tasks when you have a finish-to-finish cascade. These are okay if they're comfortably out in the future, but a subsequent lengthening of a task duration will likely have effects not modeled by the CPM. When a loose-ended task has started, its remaining duration is now uncontrolled. You could extend the task out for years with no apparent impact to the project. This is unlikely. Similarly, a loose-started task could be forecast with a longer duration. CPM solution is just to start it earlier. Realistically, additional logic or ties should be made. In any case, VU can identify these for you. Generate float analysis. This will instantly generate raw data for simple float histograms. Just paste the values into Excel. Let's show you what these reports look like. Okay, in 0.2 of a second. Basic stats there. Your open-endeds, uncompleted open-ends, and it does divide whether they're completed or not. Lag relationships. What was that? Your constraints. Constraints on actual finishes, non-operating front-end start constraints, violated back-end constraints. So I guess there were none here. Violated back-end finish constraints, expected finishes. We're okay on those. Long durations. You get the idea. Calendars. There's calendars and holidays there for you. Check your schedules, calendars, whether you have them all there or not. Tasks likely driven by the data date. You get the picture. The second way to analyze is with the schedule-to-schedule comparisons on the right. They are available only if a baseline has been loaded. Generate variances more negative than. You supply the threshold in days. Differences in current and baseline starts or finishes greater than the threshold are reported. Some project teams rely heavily on variance reporting for control. For them, this is useful. Observe the signage convention. Negative is late, negative is bad. Generate non-diminishing remaining duration since the baseline. These are tasks where the remaining duration has not budged or perhaps has increased. You can be sure there are execution problems with these tasks. Generate new tasks since the baseline and deleted since the baseline. These are self-explanatory. This option can be used to monitor scope introduced in the schedule from development or change orders. Okay, let's run some examples here. We've got these checked. Generate. So here of our completed task, we had one with some variance there of 11 days. The uncompleted have quite a few more. The non-diminishing remaining durations task is started. These, they didn't drop at all. This one actually the recreate steps from baseline to current button is the third way this tab can analyze a schedule and is perhaps the most powerful. It even allows multiple schedulers to work on copies of the same schedule and later merge these changes perfectly. This deserves its own video. In the meantime, read the help file on this. A more common use of this feature will be in claims work where you need to know exactly what changed from one version of the schedule to the next in a simple, compact, human-readable format. Let's take a look. Okay, we're going to run it here. Overwrite's okay. 0.4 of a second. If you want to get from the baseline to the current, delete the following tasks, add the following tasks, make the following modifications. There, and make some WBS changes in the paths, and then you got your current schedule. All that analytical power in one tab. We'll cover the next tab, Precedence Reports, in part 3 of this tutorial. Thank you.